Introduction. Tanuj, what are you watching? I'm watching Wild Safari on the Discovery Channel. Nice. It is quite interesting and knowledgeable program. Aditya, would you please step aside? My remote is not working. Is it working now? Yeah, thanks. But why it happened? When you came in front of remote, it didn't work. Do you know that infrared rays do not pass through the body? Infrared rays? What are these? When we press the TV remote's button, it emits an infrared wave to the television sensor. When an object comes in front of the remote, then wave doesn't penetrate that object. That's why remote does not work if any object comes in its path. But how is it possible in case of radio signals which travel very large distances? There are many types of waves having their different respective properties. Remote control works on the infrared rays and radio broadcasting works on radio waves. Infrared rays have higher frequency than radio waves. And you know that the waves which have higher frequencies, their penetration power will be lower. Okay, I got my answer. It's really interesting to know about that fact and I want to know more about this. Students, today we will study more about the electromagnetic waves. Objectives. At the end of this lesson, you'll be able to define displacement current, know Maxwell's equation, define electromagnetic waves, explain Hertz experiment, describe nature of electromagnetic waves, analyze electromagnetic spectrum. Displacement current. The current which flows through some part of an electrical circuit due to change of electrical flux with time is called displacement current. Consider a capacitor getting charged keeping the current I constant. According to Ampere's law, the line integral of B around the curve C must be equal to mu naught times the current I passing through a surface bounded by C. This means for the surface S1, closed integral of B dot dl is equal to mu naught I. But for the surface S2 through which no current flows, closed integral of B dot dl is equal to 0. It means there is an inconsistency. There must be a current associated with the changing electric field in the non-conductor between the capacitor plates. The rate of change of charge on the plates is given by epsilon naught d upon dt of EA, which is equal to epsilon naught d phi E by dt. Hence, the displacement current is given by ID is equal to epsilon naught d phi E by dt. The displacement current through the surface S2 has the same magnitude as that of the conduction current through the surface S1. Now, Ampere's law becomes closed integral of B dot dl is equal to mu naught multiplied by I plus epsilon naught d phi E by dt. Maxwell's equation. The following four equations, called the Maxwell's equations, are the fundamental equations in electromagnetism. Gauss' law for electricity. Closed integral of E dot dA is equal to Q by epsilon naught. Gauss' law for magnetism. Closed integral of B dot dA is equal to 0. Faraday law, closed integral of E dot dl is equal to minus d upon dt of phi b. Ampere-Maxwell law, closed integral of B dot dl is equal to mu naught IC plus mu naught epsilon naught d upon dt of phi e. Electromagnetic waves. Electromagnetic wave is the disturbance produced in space due to variation in electric and magnetic field vectors at right angle to each other and also at right angle to the direction of propagation. These waves are transverse in nature. The velocity of these waves in free space is equal to the velocity of light, which is equal to 3 into 10 raised to the power 8 meter per second. The electromagnetic wave are produced by an accelerated or decelerated charge of LC circuit. The frequency of EM waves is given by 1 upon 2 pi under root LC. Example. Let's take an example of electromagnetic waves. In a plane electromagnetic wave, the electric field oscillates sinusoidally with a frequency of 2 into 10 raised to the power 10 Hertz and amplitude 48 volt per meter. What is the wavelength of the wave? What is the amplitude of oscillating magnetic field? Show that average energy density of electric field equals the average energy density of magnetic field. Let's see the solution. Given values are nu, which is equal to 2 into 10 raised to the power 10 Hertz, E naught equals 48 volt per meter. We know that lambda is equal to C upon nu. By putting and calculating the values, we get wavelength of the wave, which is equal to 1.5 into 10 raised to the power minus 2 meter. We know that B naught is equal to E naught upon C. By putting and calculating the values, we get amplitude of the magnetic field, which is equal to 1.6 into 10 raised to the power minus 7 Tesla. Energy density of electric field is given by half epsilon naught E square. Energy density of magnetic field is given by half mu naught B square. We know that E is equal to CB and C is equal to 1 upon under root mu naught epsilon naught. On solving the above two equations, we get average energy density of electric field equals the average energy density of magnetic field. Hertz experiment. Hertz experiment. An induction coil is connected to two large metal spheres with a narrow gap between them to form a capacitor. Electrical oscillations are excited in the circuit by sending short voltage pulses via the induction coil to the spheres, charging one sphere positive and the other negative. In this ionized state, the electrons and ions in the air gap oscillate back and forth with the same frequency nu as that of the circuit. This process results in the production of electromagnetic waves of frequency nu. This circuit is called a transmitter because it produces electromagnetic waves. The receiver circuit consisted of a single loop of wire connected to two spheres has its own effective inductance, capacitance and natural frequency of oscillation. Observations. When the resonant frequency of the receiver was matched to the transmitter, there is an energy transfer from the transmitter to the receiver in the form of sparks in air gap. The energy transferred was carried in the form of electromagnetic waves. When the gap in the receiver is perpendicular to the gap in the transmitter, no spark appears at the receiver gap. That is, no electromagnetic wave is detected. When the two gaps are parallel, the production of sparks in the receiver gap is maximum. Nature of electromagnetic waves. Electromagnetic waves are neutral, so they are not deflected by electric and magnetic fields. The electromagnetic waves show properties of reflection, refraction, interference, diffraction, and polarization. In electromagnetic wave, the electric and magnetic fields are always in the same phase. The electric vector of electromagnetic wave is responsible for optical effect and is also called the light vector. In an electromagnetic wave, the energy is propagated by means of electric and magnetic field vectors in the direction of propagation of wave. In an electromagnetic wave, the average values of electric energy density and magnetic energy densities are equal. The speed of electromagnetic waves in a material medium is given by the relation nu is equal to C upon N. Electromagnetic spectrum. The classification of EM waves according to frequency is the electromagnetic spectrum. There is no sharp division between one kind of wave and the next. The classification is based on how the waves are produced or detected. Let us describe these different types of electromagnetic waves in order of decreasing wavelengths. Radio waves. Lower frequency radio waves are generally produced by charges accelerating through conducting wires using electric oscillator circuits. They are used in radio and television communication systems. They are generally in the frequency range from 500 kHz to about 1000 MHz. Cellular phones utilize radio waves to transmit voice communication in the ultra-high frequency band. Microwaves. Microwaves with frequencies 3 GHz to 300 GHz range are produced by special vacuum tubes like klystrons, magnetrons, and gun diodes. Due to their high frequency or short wavelengths, they are suitable for the radar systems used in defense and aircraft navigation. Microwave ovens are domestic application of microwaves. Infrared waves. This covers wavelengths from 10 raised to the power minus 3 meter down to 7.8 into 10 raised to the power minus 7 meter. These waves are produced by molecules and hot bodies and are sometimes referred to as heat waves. They have many applications in industry, medicine, astronomy, etc. Infrared radiation also plays an important role in greenhouse effect. Infrared detectors are used in Earth satellites, both for military purposes and to observe growth of crops. Infrared waves are widely used in the remote switches in the household. Visible rays. This is a narrow band formed by the wavelengths to which our retina is sensitive. It ranges from about 4 into 10 raised to the power 14 Hertz to about 7 into 10 raised to the power 14 Hertz. Light is produced by atoms and molecules as a result of internal adjustment in the motion of their components, principally that of electrons. The different sensations that light produces on the eye, called colors, depend upon the frequency or the wavelength of the electromagnetic waves. Different animals are sensitive to different range of wavelengths. Ultraviolet rays. This region covers from 400 nanometer down to 0.6 nanometer nearly. These waves are produced by atoms and molecules in electrical discharges. The sun is a very powerful source of ultraviolet radiation, and it is this factor which is mainly responsible for suntans, but most of it is absorbed in the ozone layer. UV light in large quantities has harmful effects on humans. Welders wear special glass goggles to protect their eyes from large amount of UV produced by welding arcs. UV rays are used in eye surgery, and UV lamps are used to kill germs in water purifiers. X-rays. X-rays having wavelengths from about 10 nanometer to 10 raised to the power minus 4 nanometer. X-rays can be generated by bombarding a metal target by high-energy electrons. X-rays produce profound effects on the atoms and molecules of the substances through which they propagate, such as dissociation or ionization. X-rays are used in medical applications such as diagnostic tool in medicine and as a treatment for certain forms of cancer. Gamma rays. These electromagnetic waves are of nuclear origin. Gamma rays lie in the upper frequency range of the electromagnetic spectrum and have wavelengths from about 10 raised to the power minus 10 meter to less than 10 raised to the power minus 14 meter. Gamma rays produced by many radioactive substances and are present in large quantities in nuclear reactors. These radiations are also emitted by radioactive nuclei. They are used in medicine to destroy cancer cells. Did you know? Maxwell was the first to understand fully the connections between time-varying electric and magnetic fields and to propose a set of equations for these. He showed that light is an electromagnetic wave. He developed a quantitative theory of color vision. Long waves are lower in energy than short waves. Long waves from space penetrate the Earth's atmosphere easily. The ionosphere, between 45 and 250 miles above the Earth, can reflect radio waves. Interference can affect the quality of the received radio signal, making it sound crackly or appear snowy or even show ghosts on a television picture. Summary. Let us summarize what we have learned. The current which flows through some part of an electrical circuit due to change of electrical flux with time is called displacement current. EM wave is the disturbance produced in space due to variation in electric and magnetic field vectors at right angle to each other and also at right angle to the direction of propagation. The electromagnetic waves show properties of reflection, refraction, interference, diffraction and polarization. In electromagnetic wave, the average values of electric energy density and magnetic energy densities are equal. The classification of electromagnetic waves according to frequency is known as the electromagnetic spectrum. Radio waves are produced by the accelerated motion of charges in conducting wires. Visible light emitted or reflected from objects around us provides us information about the world. Our eyes are sensitive to this range of wavelengths. Gamma rays are produced in nuclear reactions and are also emitted by radioactive nuclei.